Good day, viewers. My name is Mohamed Kouma. You are welcome to our YouTube channel, Professional Academy. Today, we are going to be looking at mensuration. After sending a lot of questions in our WhatsApp channel, we have realized that a lot of students are still struggling with mensuration. So let's start with mensuration. First of all, if you are asked what is mensuration, mensuration is all about it's a branch of math that deals with the study of the measurement of the perimeter, the area, and the volume of shapes. Okay, let me repeat it again. Mensuration simply means it's a branch of mathematics that deals with the study of the perimeter, the area, and the volume of shapes. Okay, so there are there are different or various types of mensuration. Today we are going to be looking at the solid mensuration. As far as WAEC is concerned, there are two main types of mensuration they do talks about. The other one is a plane mensuration and the other one is a solid mensuration. Okay. Now for solid mensuration, it involves the for solid mensuration involves studying the area of shapes and also the volumes of shapes. Okay. While for a plane mensuration, this one just deals with the study of the perimeter and the areas of the shapes. So most cases, this one has a volume because solid is about three-dimensional object, while for plane mensuration involves mainly two-dimensional objects. I hope it's clear, right? So now the solid mensuration we are going to be looking at, there are a lot of shapes we are going to be looking at, but for today's class we are going to be looking at the cylinder. Okay, then the next class we'll be looking at cone, and until we finish everything about the solid mensuration. So let's start with a cylinder. If I say a cylinder, I guess majority of you know what a cylinder is, right?
Yes.
Okay, a cylinder, I have an example here just to click your memory. This is called a cylinder. Okay, so this one is a good example of a cylinder. Now, sometimes you may be wondering, there are certain shapes that resemble a cylinder, but they are not cylinder. One of those shapes will look like a frustum. A frustum, sometimes it looks like a cylinder, but how will you identify if something is a cylinder or a frustum? A frustum, the upper part and the down part are not equal. You see shapes like this sometimes, like this tea cup or this cafe cups. You see those shapes like this, they are what? Frustum, meaning the upper and down are not equal. But for this cylinder, both the down part, the bottom part, and the top part, they are both equal. So before going further, one of the questions you may be expected, or some of the questions are, you need to know how to find the area of a cylinder. So these are the questions we are going to be answering. The next one is finding the volume of a cylinder. So these are the questions we are going to be answering as far as this video is concerned. Okay. So before going further, I want us to know how do we derive the formula for area of a cylinder. Now, area of a cylinder, let's start with the area of a cylinder. To derive it, we have to take a look at the cylinder itself in order to be able to derive what's the area of a cylinder. Okay, I brought here a cylinder. You maybe recognize this one as a cylinder. It was breaking down just so that I can able to explain it further. Okay, so if you look at this cylinder, let's look at that. We have a top part, which is a circle. It's a cover here. Then we have the bottom, which is also a circle, right? Then we also have a curve, right? This is a curve area. It's a curve area. Okay. All right. So here I just cut the bottom part of this cylinder. I just want us to have a clue on how the formula came about. So as you see, this is the upper part and this is the bottom part. Okay. Now, if we want to see much clear, let us dissect it here, like to cut it. If I cut this one, you realize that this is a curve, right? You know, this is the curved part of the cylinder, right? And this one was the bottom part, and then up was the cover itself. So this is the curved surface of the cylinder. So now, without wasting time, let's just try to cut it down, and you can see what I'm talking about. Let me cut it down a bit. You don't want to pause here. Now, after cutting it, you can see this is a curved surface area, right? So let's put it on the board and see it clear. So there are two circles, as you can see. So we have a circle here. Then we also have another circle here, because there is up and there is down. So, and then this curve, the curve, if I break it down, what do you notice? The curve, if I break it down, what do you notice? It's a rectangle now, right? So let's write it down. In the middle, there's a rectangle. So it's like this is a rectangle, because after breaking everything, you have a circle here at the other side, and there's a circle here on the other side. So, but we know that for a circle, to find the area of a circle is, let's say this is a radius here, then there's a radius here. Okay. Now, to find the area of a circle is pi r square. We all know that. So, area of a circle is equals to pi r square. But how many circles are there now together? There are two circles, right? One up and one down. So that will give us 2 times 2 of that. That will give us 2 pi r square. So this is the area of the two circles. What about the area of the curve? That's the rectangle we are having here. In order to find the area of a rectangle is what? It's length times the breadth. So the length here is nothing but the circumference, because if you can remember, let's try to put it back together and you see. Is it not the length here? This is the length. After cutting it, this is the length, right? So, but if you recall again, this was a circle. It fits into the circle. So since it fits into the circle, it means the length here is nothing but what? The circumference of this circle. The length is nothing but the circumference of the circle. Okay. So this length we see now, it is the circumference of this circle. Okay. So instead of putting length, I will just say, okay, it's all is equals to 2 pi r, because circumference is equals to 2 pi r, right? Now, after doing that, but the breadth here is nothing but the height of this cylinder, the height. So therefore, this becomes the height. Okay. Now, how do we find the area of a rectangle? We know that area of a rectangle is equals to length times breadth. So for the area of the circle, now we go for area of the rectangle. So area of a rectangle is equals to length times the breadth, which is nothing but, since we know that the length is the circumference, because the length was the one surrounding the circle, so that makes it to be the circumference of the circle, and the breadth here is nothing but the height of the cylinder. So I can just write 2 pi r times the height. So that gives us now 2 pi r h. So this is the area of the rectangle, while this one is the area of the circle. To sum it together now, that means to sum the area, total area now for a cylinder is equals to the area of a circle plus the area of the rectangle. So where the C and the R represent circle and a rectangle. So the area of that of a circle is 2 pi r square, plus that of the rectangle is what? 2 pi r h, right? So this gives us what? The total area of the rectangle, which the cylinder, which if I factorize out the 2 pi r is common, I can have r plus h. So this is the total area of a cylinder. But some case will have a scenario where the cylinder will have an open side. So this is the total area of a closed cylinder because there are two circles present. What if my cylinder here, let me show you again. Now this is a cylinder. The cylinder is open. There is an open cylinder, right? In this scenario, one of these side is removed. Only one side is left. So in order to find the area, what should I do? Now, in that case, let's say there is open cylinder. So you have to know the difference. When the question say an open cylinder or a closed cylinder, there's a difference. You know, for closed cylinder, there are two circle present, both up and the down one. But for open cylinder, meaning one side is closed while the other side is removed. So to find that, since we know that, let's rewrite it again. As we open it, we got a rectangle here. We have a one circle here. This one has been removed, no more, right? So since we know that this is the radius and we know this length is nothing but the circumference, 2 pi r, then here is the height. So to find the total area of this open cylinder is going to be equals to, let's find the area of the circle first. That's going to be just pi r square because it's one circle, so it's just pi r square. But for a rectangle, we know the area for the rectangle we got is equals to the 2 pi r h, which we got earlier. So we have 2 pi r h. So to find the total area, area total for this open cylinder is just going to be, we add the 2 pi r square all plus 2 pi r h. So this gives us the total area of the cylinder. But here, since the pi r is common, I can just factorize pi r, which will give us r plus 2h. So this is the area of a cylinder when it is an open cylinder. So this is the area of an open cylinder, okay? Now the next, since we know how to derive these formulas, the open cylinder and the closed cylinder, let's look at how do we find the volume of a cylinder. To find the volume of a cylinder, the only thing you need to know is the area of the base times it by the perpendicular height. The area of the base multiplied by the height. So that will give us the volume of the cylinder. So the volume of a cylinder is just the area of the base area times the perpendicular height. So the volume of a cylinder will be equals to the area of the base times the height of that of cylinder. And the area of the base here is nothing but the circle here. The area of the base is nothing but the circle, which means the area now is going to be pi r square times the height is just h, which is h. So that will give us the volume of a cylinder to be pi r square multiplied by the h. So this is the formulas we are going to be dealing with when solving for the area of a cylinder for both closed and open cylinder. And when they say open cylinder, meaning only one side is open. And when the question say a closed cylinder, meaning both these sides are closed. I hope it's clear. First time, I just want to differentiate something. Sometimes, most of this time, students are confused with this word, curved surface area, and finding the total surface area. We know how to find the curved surface area is very simple. We know in a cylinder, this is a curve. So if you are asked to find the curved surface area, we are just finding this area, which is nothing but a rectangle. Because if you open it, you will end up with a rectangle. And we already find it here, which is the area of the rectangle in a cylinder, which is just 2 pi r h. So this is nothing but the curved surface area. So in case you are asked for the curved surface area, you don't have to mix it. Okay, so AC, that's the curved surface area. So the curved surface area is just going to be 2 pi r h. That is the curved surface area. It's just 2 pi r h because it is nothing but the rectangle. So you have to be able to distinguish it. If you are asked in an examination, an open cylinder have this data and you are given the values to find the total area, total surface area. It means you add the curved surface area plus the area of the circle. This is the curved surface area plus the area of the circle. But in case the is a closed cylinder, then you have the two circles, then you add it to the curved surface area, which is the 2 pi r square. Then you have the 2 pi r h, which is the area of the curved surface. So this is the area of the curved surface. So you have to be able to distinguish between the two. Okay. So here are the formulas. So for a closed cylinder, we know the total surface area is 2 pi r into r plus h from the derived one as we derived it earlier on. So we have a curved surface area which is 2 pi r h, then the volume of a cylinder which is just pi r square h. Okay. Now if you go for open cylinder, the total surface area, you see there is a changes because one of these open was out, so the changes is there. So we have pi r into r plus 2h. Then the curved surface area will just going to be 2 pi r h. Then finally the volume of the cylinder itself is just going to be pi r square. So the only difference we have here is their total surface area. That's the only difference. But the rest, curved surface for closed cylinder and open cylinder, both of them have the same curved surface area. So here is an example of a question we are just going to be looking at. Was June 2000. The question reads, a cylindrical well of radius 1 meter is dug out to a depth of 8 meters. The question says, Roman 1 says, calculate in meter cube the volume of the soil dug out. Roman 2 says, if the soil is used to raise the level of a rectangular floor of a room 4 meter by 12 meter, calculate correct to the nearest centimeter the thickness of the layers of the soil. So let's start by sketching the diagram. So if you have a soil here, this is just a soil. So down you dig something. Let me make it size out to manage the blackboard, the whiteboard. So let's just make it a small diagram here. So you have land here, trees. So you dug a well down. So this is the level of the soil. This is level of the soil. You dug the well to a point of, and we are given the height of this well to be. The height is given to be 8 meter and the radius is given to be 1 meter. According to the question, it says a cylindrical well, the radius 1 meter and the depth, which is the height of the cylinder, is 8 meter, which is the well here. Okay. So in order to, the question asks us to calculate the volume, as we can see here from this diagram, but the question I'm having for you is this a closed cylinder or open cylinder? Since we dug the well out, the upper part has been removed. It's only the down that is there. So definitely it's going to be an open cylinder. So the volume for the cylinder, which is the Roman 1 here, we say the volume. Since we know that volume of a cylinder is going to be pi r square, then multiplied by the h. So where the question will give us, the pi is given to be, according to the question, it said take pi as 22/7. So if we place our values, let's take the data from this. From here, we know the radius is going to be 1 meter and the height is what? 8 meter. Then our pi is given to be 22 all divided by 7. So in that case, if I put the values in, the volume now will be 22 all over 7 times the radius. But here the radius is squared, so that will be 1 then all squared times by the height, which is 8. So if I do that, that will give us 22 all divided by 7 times 1 square will be just 1 times 8. If I use a calculator to multiply it together, that will give us, let me put it in a calculator, we have 22 times by 1, then times by 8, we will have 176 all divided by the 7 down, which if I put in a calculator will give us 25. So it's going to give us 25.143 meter cube. So let's read the instruction, because the question says calculate in meter cube the volume. So we are not given instruction whether 1 decimal place, 2 decimal place, or 3 decimal place. So we can just leave it into 2 decimal place. So that will give us 24.14 meter cube. So this is the volume of the soil dug out, because we know that if we know the volume of the cylinder itself will be the same as the volume of the soil that was inside. So definitely that will be the answer for Roman 1. That is the volume of the soil dug out. Okay. Now, if this volume of the soil was dug out, the next question now goes, if the soil is used now to raise a level of a rectangular floor of a room. Let's use our calculator again as just an example of a cylinder. This calculator will be like a rectangular floor. Okay, like a rectangular floor. We call it a cuboid. When you go, we will talk about them later in the series of this video. So if you have this floor like a room like this, then you bring the soil out, you place it inside this rectangular floor. That is your room. Definitely the soil, the volume of the soil you obtain from this will be the same as the volume of this rectangular floor, because the question goes ahead and says level of the rectangular floor of a room 4 meter by 12 meter. Calculate correct to the nearest centimeter. How high will this soil fill the room? That's the question. How high will it fill the room? So that means the thickness or the height of the room it will fill. So since we know this is the room we are dealing with, just an example actually. So we know that the volume of a room, we know a room is going to be like a cuboid. So to find that, we know the volume will be length times the breadth times height. But what you should know that these two volumes must be equal, because this soil is going to be used to occupy inside the room. That means the volume are going to be equal. And we are given the length and the breadth, then we are finding the height. That's the thickness of the soil. I hope that is clear. That makes sense. Okay, so now let me just prove it to you just in case. Here is the soil dug out from the cylinder. I just brought some soil particles here just to explain it a bit further. So here, what if you notice that if I take this soil of this cylinder, turn it to this one, it reaches to a certain level. So now they are asking us how high the soil reaches, occupy in this cylinder. So without wasting time, we just go straight and say, since we can just say the length there is of the length of the, let's take data from that question. So from this, we know that the breadth of the room is 4 meter and the length will be 12 meter. Then we don't know the height, which is question mark. But from this formula, we know volume is equals to length times the breadth times the height. So which if I find it, that will give me volume is equals to length is 12 times the breadth is 4 all multiplied by the height. So definitely if I use my calculator here, that will give us 12 times 4, that is definitely 48. So we have 48 H. So the volume of the rectangle is 48. Since we know that the two are equal, the two volumes we got, they are both equal, because the soil dug from here is the same soil place, so the volume must be equal. So if I equate the two now, the volume of a cylinder must now be equals to the volume of the rectangle we obtain. So the volume of the cylinder is 25.14, all is equals to 48 multiplied by the height. So if I divide by 48, if I go this, cancel this, so definitely the height will be, let's divide it and see what we'll have as the answer. So we have 25.14 all divided by 48. So that will give us 0.5237 or 38. Let me just say 542. Okay. Now in meter, it's meter because everything is in meter. But don't forget the question say in the nearest centimeter. So meaning in order to solve in the nearest centimeter, we have to convert the meter into centimeter. So let's clear some space so we can have it at this. Let me just clear up here. So now, okay, so the height now is equals to 0.524. Okay, and into nearest centimeter. Let's convert into nearest centimeter. We know that 1 centimeter, 1 meter is equals to 100 centimeter. So if we do that, the height here is 0.524 meter is equals to x. We know 1 meter is equals to 100 centimeter. So this meter will goes with this meter. So that will left with x times 1. That is just going to be x. All is equals to 100 times 0.524. That will give us 52.4 centimeter. But the question said to the nearest centimeter. So definitely to the nearest centimeter, our value is going to be 52 centimeter. So this is how deep the soil occupies the floor, the rectangular floor. So thank you for watching. Make sure you share, you subscribe, and you like, comment.